Grace College of Engineering, Computer Science and Engineering Department, Digital Systems Laboratory. Exercise number 8B, Coding Combinational Circuits using HDL. Aim: to simulate the combinational circuits using HDL simulator, that Verilog module. First, half adder. This is a truth table. This is a circuit diagram of half adder. This is the module. For module, file name, variables I am taking A, B, S, C, and input A, input B, 2 inputs and 2 outputs. That is output sum, output carry, then assigning the values, then end module. Let us see the implementation of half adder using Xilinx software. This is software. Double click. Software is opening. Wait for some time. Software open. Then click the file. New project. This is a folder name. I am giving DigiLab. Then click next. Then next. Then finish. A folder is created. Then this is a program. Right click. New source. Here click this Verilog module. Then give the file name. We are doing half adder. I am giving the file name H. Then next and finish. Here you want to type the program. Okay, this is a program. Then next. Then click the file. Save the program. Want to check the syntax. For that, click this synthesis. There will be check syntax. Right click that. Run. We got the green tick, so syntax is correct. Then in the top module, click the file name, that H, and enter. And then next click the simulation. Click the file name. Right click, new source. Click this Verilog test feature. Here a file name is H. Then click underscore test. Then next, then finish. After that, want to check, click this iSim simulator. There will be behavioral check syntax. Right click and click this run. Running process going on. We got the green tick, so our syntax is correct. Then click this, click the top module, file name, and enter. And then click the simulate behavioral model. Right click, run. We get the new window. Here we can check the truth table. For A, I am right click, force constant. I am giving the value 1. Apply, then OK. And then next click the B, right click, force constant, click 1, apply and OK. Then click the file, save, and then this is a run button. Click that. See, you got the answer 1 1. Sum is 0. This is a carry. Carry value is 1. Then click this button for you can get the clock sign. Right? So we have successfully implemented the half adder and verified the truth table using Xilinx software. Full adder. Truth table of full adder. We will give 3 inputs and output will be 2. That is a sum and carry. According to that sum and carry, we want to construct the K map. So separately we have constructed for sum and carry. From the value, we want to design the circuit diagram. This is a Verilog module for full adder. Module, file name, that is F, and the values are A, B, C, S and out. Input, 3 inputs given, input A, input B, input C, output sum, S is a sum, and carry value is C out. Carry value will be C out, then assigning the values, then finally end module. Let us see the implementation of full adder using Xilinx software. This is software, double click, software is opening. Then click the file name, new project. Here you want to give the folder name. I give the digital lab, then click next. then click next, then finish. Folder is created, then click the file name, right click, new source. Here click the Verilog module, full adder, right? I am giving the file name here, then click next, then finish. Here you want to type the program. Okay, this is a full adder program I typed, and next you want to check the syntax. Before that, file, save the file, click the file and save. After that, here click this implementation, that there is a synthesis. In that there will be a check syntax, right click, run, running process going on. We got the green tick, so syntax is correct. Then in the top module, click the file name here and click enter, and then click this simulation. Before simulation, you want to do the test file, create the test file, click this file name, right click, new source, Verilog test feature. Here file name underscore test, then click next, and then next and finish. After that, you want to click that test file. There will be a behavioral check syntax, right click, run. We got the tick, green tick, so behavioral check syntax also correct. Then in the top module, click the file name and enter, and then click this simulate behavioral model, run. The new window will come. There we can check the truth table. In that A, I am giving right click, force constant. Here I am giving the value 1, then apply, then OK, and then next click the B value, force constant. I am giving the value 1, apply, then OK. Then for C, right click, force constant, giving the value 1, apply, OK. Then click the file, save the file. This is the run button, click this. See, I have given A, B, C 1 value, sum is 1 and the carry is 1. So truth table is verified. Then click this button, this is a clock sign. So we have successfully implemented full adder and successfully verified the truth table using Xilinx software.
Next, multiplexer. Verilog module. Here in multiplexer, we will give 4 inputs and we can get 1 output. This is the output. This is the truth table for multiplexer. In demultiplexer, this is opposite. We will give that is opposite to multiplexer, that is a demultiplexer. This is a Verilog module. This is a truth table of demultiplexer, and this is a output.
Let us see the implementation of multiplexer using Xilinx software. This is a Xilinx software. Double click. Software is opening. Software open. Then click the file name, new project. Here you want to give the folder name. I am giving DigiLab. Then click next. Then next. Then finish. After that, here the folder is created. This is the file name. Right click the file name, then new source, then click the Verilog module. Here we are going to do multiplexer, so I am giving MU. Then next, then click finish. Here write the program. Already I typed, so I have copy and pasted. File name, I change the file name MU, then click the file, then save. Then click this implementation. Here in the top you want to check the syntax. Click the synthesis. There will be check syntax. Right click that. Run. Running process going on. We got the green tick, so syntax is correct. Then in the top module, click the file name MU. Then click enter. Then click this simulation. Here click this file. Right click, new source. Click Verilog test feature. File name is MU, then underscore TEST, then next, then finish. Then after After that, you want to click the test file. In the top module, click the file name MU, then enter. Then click this iSim simulator. There is a behavioral check syntax. Right click, run. Running process going on. We got the green tick. So behavioral check syntax also correct. Then click the simulate behavioral model. Then click run. We get the new window. Here only we can check the truth table for multiplexer. For I0, input 0, right click, force constant. I am giving value 1, apply, OK. And for I1, right click, force constant. I am giving the value 1, apply, then OK. Then I2, right click, force constant. Here I am giving value 0, apply, OK. For I3, right click, force constant. Value 0, apply, OK. Then set, here also force constant. I am giving the value 0, 0. Then apply and OK. Then file, save the file. This is the run button. Click this run. You got the answer. See 1, 1, 0, 0. You got the value, output is 1. The truth table is verified. Thus we can verify all the values. Then click this. There will be a clock sign is presented. So we have successfully verifiable for multiplexer.
Thus we have implemented combinational circuits successfully and verified the truth table using Xilinx software. Thank you.